Hi everyone, it's Mrs. Summer here to talk about the Unit 6 review. So the first part is dimensional analysis. It says to convert 3,652 feet to miles, remembering that 5,280 feet is in 1 mile. So the way we set this up was our 3,652 feet on the outside. My conversion factor is under here. That way my feet cancel and I'm left with miles as my answer. And when I do that math in my calculator, I get 0.69 miles. The next one is convert 3.5 hours to seconds, remembering that 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds. So you can use your railroad tracks to do this. So here we set it up. We want our hours to cancel first. So I have my 3.5 on the outside because that's what I was given. Then I have my 60 minutes in 1 hour because we can't go directly from hours to seconds. So then I get 60 minutes in 1 hour. Then my next conversion factor is 60 seconds over 1 minute. And that way my minutes cancel and I'm left with seconds as my my unit. And when I do that math, I do 3.5 times 60 is equal to 12,600 seconds. So the next part, 602, was what's a mole? So what is the definition of a mole? A mole is a counting unit. At its very basics, it's a counting unit. A good analogy is our comparison for the mole is like 1 dozen equals 12 eggs. So how many dozens did you have? Oh, I had 3 dozen, which means that there was 36 eggs. And define and describe Avogadro's number. Avogadro's number is that a mole of something is 6.02 times 10 to the 23rd atoms, ions, molecules of something. This number, 6.02 times 10 to the 23rd atoms, ions, molecules, is Avogadro's number. The next lesson was mole-to-mole ratios. So given the balance equation, what is the mole-to-mole ratio of N2 to NH3? So in this one, we have 1 mole of N2 because there is no coefficient in front of N2, to 2 moles of NH3 because 2 is the coefficient in front of NH3. The next question was how many moles of ammonia are produced if 6 moles of N2 are fully reacted with H2. So how many moles of ammonia are produced if 6 moles? So 6 moles is what we start with, 6 moles of N2. And when I do that, then I'm using my mole-to-mole ratio, so my 2 moles to 1 mole, and I want my moles of N2 on the bottom, so I put that 1 mole of N2 on the bottom, and my 2 moles of NH3 on the top, so I'm left with 6 times 2, which is 12 moles of NH3. So the next part, lesson 604, was calculating molar mass. So this question is calculate the molar mass for the following compounds, so C6H12O6. So carbon, there are 6 carbon atoms, carbon's atomic mass, and that's from the periodic table. So you need to find it on the periodic table. So 6 times the atomic mass of 1 carbon atom is 72.06. Then my hydrogen is 12, because there are 12 hydrogens in that compound, times 1.01, which you get from the periodic table. And then oxygen is 6 times 16. And when you add them all together, the molar mass of C6H12O6 is 180.18 grams per mole. The next compound that you needed to calculate the molar mass for was NH42SO4. And so by doing that, I have 2 nitrogens times the molar mass of nitrogen, 8 hydrogens times the molar mass of hydrogen, 1 sulfur times the molar mass of sulfur, and 4 oxygens times the molar mass of oxygen, all totaled is 132.07 grams per mole. This next compound we have is KAlSO42. So we have 1 potassium at 39.10 equals 39.10. 1 aluminum times the molar mass of aluminum. 2 sulfurs times the molar mass of sulfur. 8 oxygen times the molar mass of oxygen. And then when you add them all together, you get 258.22 grams per mole. So this next question is grams to moles, or moles to grams, sorry. So how many grams are in 3.2 moles of H2O? So here we need to use the molar mass of H2O. So we're starting with moles of O2. This is supposed to be say how many grams are in 3.2 moles of O2. And we're going to go like that. We need the molar mass of O2. So then the molar mass of O2 is 32 grams per 1 mole. I write it like this as my conversion factor because I want my moles of O2 to cancel. And I'm left with 3.2 times 32.00 equals 102.4 grams of O2. My next one is if I have a balloon with 6.8 moles of helium, how many grams of helium are in the balloon? So I have 6.8 moles of helium, the molar mass of helium over 1 mole. So my moles cancel, and I'm left with 27.2 grams of helium. Now we're going the opposite. We're going from grams of something to moles of something. And therefore, we have to divide by the molar mass. So how many moles are in 73.8 grams of SO2? So here I have my 73.8 is what I started with. My molar mass is 1 mole because I want moles in my unit. And I want to cancel my grams. So 73.8 times 1 divided by 64.03 equals 1.15 moles of SO2. This next question says a scientist measures out 83.6 grams of Mg3PO42. How many moles does he have? So I'm starting with the grams, 83.6 grams of Mg3PO4, 1 mole over 262.87 grams equals 0.32 moles Mg3PO42. Now here's the question that a lot of people got stuck with on their mastery checks because they forgot to write the charge on the ion. But 3 moles of Mg2 plus, so ions. So now we're going into Avogadro's number. We're using that 6.02 times 10 to the 23rd. And so I'm going to do 3 times Avogadro's number because I have moles. I want my moles to cancel. And I'm left with 1.81 times 10 to the 24th ions of Mg2 plus. So if it's asking for an ion, you got to give the charge. This next question asks how if I know I have 0.024 moles of NaCl, how many molecules are there in my sample? So I'm starting with 0.024 moles of NaCl, multiplying by Avogadro's number, and I get 1.44 times 10 to the 22nd molecules. Now here we're doing the opposite. We're starting with molecules, and we want to know how many moles. So I'm starting with my molecules, so my Avogadro's number has to be on the bottom. So I'm taking 4.5 times 10 to the 12th and dividing it by 6.02 times 10 to the 23rd, and my answer is 7.48 times 10 to the negative 12th molecules of MgO. So this last question says a test tube has 8.7 times 10 to the 45th atoms of calcium. How many moles is that? And the work is on the next page. So from that previous question, I start with 8.75 times 10 to the 45th. And when I do that math, I get 1.45 times 10 to the 22nd. Now we're getting into what volume does this many moles of O2 fill at standard temperature and pressure. Remember, our volume conversion is 22.4 liters. So I have 5.23 moles of O2 times 22.4 liters to get 117.15 liters of O2. This next question is how many moles of H2 gas will fill 3.82 liters at STP? So now I'm starting with liters, so 3.82 liters, and so I need to divide by my liter conversion to get 0.17 moles H2. Okay, now we're into stoichiometry. It says the mineral magnesite contains magnesium carbonate, magnesite can decompose with heat to form magnesium oxide and carbon dioxide. How many moles of magnesium oxide would be formed when the reaction of 2100 grams of magnesite? So when we set this problem up, I've got my 2100 grams of MgCO3. My molar, I need to go from grams to moles of MgCO3. So I use its molar mass. Then I'm going to multiply by the molar ratio between MgO and MgCO3, which in this case is 1:1. And I'm left with, when I do the math, I do 2100 times 1 divided by 84.32 times 1 divided by 1 equals 24.91 moles of MgO. This question says propane, which is C3H8, burns in oxygen to produce carbon dioxide and water. What mass of propane could be combusted by 8.35 moles of oxygen? So here we have the balanced equation. So we're starting with 8.35 moles of O2. So we're starting with moles, so we need to use the molar ratio to go from moles of O2 to moles of C3H8. So that is a 1:5 ratio. Then I need to use the molar mass of C3H8 in order to determine the grams. So I do 8.35 moles times 1 divided by 5 times 44.11 to get 73.66. Here, this next question is limestone will react with most acids to form a calcium salt, water, and carbon dioxide. Determine the liters of carbon dioxide produced if 0.65 moles of calcium carbonate are allowed to react with phosphoric acid according to the following equation. So I'm starting with 0.651 moles of calcium carbonate. And then my mole ratio is 3 moles of CaCO2 to 3 moles of CaCO3 because it's a 3:3 ratio. Then I'm going to use my liters conversion, so 22.4, because it says determine the liters of CO2 produced. So I want liters in my end. When I do 0.651 times 3 divided by 3 times 22.4, I get 14.58 liters CO2. This next question says that tin 2 fluoride, also known as stannous fluoride, is added to some dental products to help prevent cavities. How many grams of tin 2 fluoride can be made from 55.0 grams of hydrogen fluoride if there's plenty of tin? So I'm starting with 55.0 grams of hydrogen fluoride. I need to go from my grams of hydrogen fluoride to moles of hydrogen fluoride using the molar mass. Then I'm going to go from my moles of hydrogen fluoride to my moles of tin 2 fluoride using the molar ratios from the balanced chemical equation. Then I'm going to use the molar mass of tin 2 fluoride to convert my answer to grams. So I do 55.0 divided by 20 times 1 divided by 2 times 139.71 equals 192.10 grams SnF2. This last question is oxygen was discovered by Joseph Priestley in 1774 when he decomposed mercury 2 oxide into its individual elements by heating it. How many grams of oxygen could Priestley have produced if he had reacted with 216.59 grams of mercury 2 oxide? So I'm going to start with 216.59 grams of mercury 2 oxide, convert to moles of mercury 2 oxide using the molar mass, then use my molar ratio between my oxygen and my HGO, which is a 1:2, and then use the molar mass of O2 to convert to grams of O2. So if I do 216.59 times 1 divided by 216.59 times 1 divided by 2 times 32, I get 16.00 grams of O2.